Yeah, yeah, it started. Uh, my name is Fahad Ullah. My ID is 23101. Today, my presentation topic is limiting factors for online purchasing in grocery sector. My team consists of 6 members. So I'll start the overview. In today's rapidly evolving digital landscape, imagine ordering groceries online to face a 40% chance of delivery delays during peak hours, or being among those 25% of seniors who abandon their shopping carts due to the complex interfaces. This is the reality facing UK online groceries adoption today. So we will explore the key constraints shaping UK online groceries adoption, starting with our research questions, data sources before exploring methodology and literature insights. We will then present our main findings: delivery reliability, cold chain gaps, digital exclusions, and environmental impacts. And finally, application, actionable recommendation with KPIs, and conclude the future research directions. So, moving to the abstract. So, to provide a quick overview to our study, let's look at our abstract, our main question, that what are the key constraints affecting UK online groceries adoption. So, in the solution, we employed a comprehensive methodology utilizing various government data sources. We analyze environmental impact metrics from DEFRA, GPIC dashboard, demands patrons from the ONS Energy and Retail dashboard, and conducted a cold chain analysis using the DEFRA farm survey. We also considered user experience from the UK Digital Index. So our key findings highlight several significant challenges. We found that 40% of uh, e-card deliveries delays is concerning statistics from ONS. And furthermore, less than 50% of the UK farms currently have automated cold storage as per DIPRA data. From this social perspective, that 25% of the seniors are excluded from the grocery because of the complexity in the user interface, as according to the UK data index. Furthermore, my friend will explain. Thank you.
Hi, my name is Fahad Ullah, and my student ID is 2309177. I will present my topic, that is the numbers tell a comparing story. Online grocery sales size 78% post-COVID, yet we are seeing a troubling 30% card amendment rate in 2025. Additionally, 19% of rural area face broadband gaps that limit real-time inventory access. Explanation of the diagram. The x-axis represent the year from 2018 to 2025, and the y-axis shows the percentage of the online grocery sales. The step upwards curve from 2019 to 2020 visually captures the immediate impact of the pandemic, accelerating online adoption, and the continuous rise of the Alberts at the slower pace post 2020, indicating the sustained growth and the establishment of the online grocery. Moving to the next slide, problem statement and research questions. Our analysis reveals the post-Brexit supply chain fragmentations and digital exertions are continuing UK on grocery growth despite the 78% COVID surge, resulting in 30% card abandonments and 40% peak hour delivery delays. We found three critical questions. First of all, we extend do code chain fragmentation gaps. Second, which specific UI cause 25% senior exertions. And the third one is, can strategic CV developments reduce the last minute emissions? And next part will be Vasu present.
Hello guys, my name is Vasu. My student ID is 23116 and I am representing the slide 5 and the 6 as well. Slide 5, our literature review reveals three key themes. The first one is delivery delay. After Brexit, improving fresh produce takes 48 hours longer than causing an 80% increase in spoiling. The second, online shopping challenge. 41% of older adults give up on buying online things because of the checkout process was 2 hours, so that's why. And the third one is environmental impact. Buying groceries online create 2.3 times more pollution than shopping in stores. And we also found a major research gap. No study has combined DEFRA sustainability measurement with ONS real-time demand forecasting mode. This combination is what makes our concern different and the new one. Now I'm moving to the next slide. Is methodology. On this slide, you can see the table. It shows the data source we use, the key metrics we focus on, and the methods we use to analyze them. From defraging, we studied defragration of 35,578 hectares using content analysis. From the owner's energy dashboard, we get CO2 in this 168 grams per kilo and is free space analysis. From the Ofra farm survey, so the refrigerant cost of 114 pounds per 12 megahertz or the spoil application coding by the analysis. Lastly, the UK Digital Index helps us to identify the major digital exclusion which was estimated with the gap analysis. By doing all this, we could better understand the main problems. The next slide my explained by the next my next colleague.
My name is Gomse Vijay. My student ID is 23084-924. Today I will talk about two slides 7 and 8. Firstly, I explain the 7th slide key finding. A significant issue is delivery reliability. We find that 40% of delivery experience delay during peak demand. A figure that's a 23% increase during heat waves. Additionally, a major scene that 50% of UK farm poses automated cold storage facilities. These issues are compounded by cost. The cost is 114.12 megawatt hour. Furthermore, we observe that 30% increase in import cost. In the 8th slide, I will talk about supply chain flow chart. At the top, we see that 114.12 megawatt hour cost and 30% import cost increase feeding into farm production. These represent rising cost and cost directly affecting the stage of supply chain. The lack of automated cold storage combined with issue stemming from farm production feed into delivery stage. All these factors coverage at the customer level. This chart visually how rising cost. In the next slide, my colleague explain.
Hello, my name is Sadnam Singh and my student ID is 230693889, and I will talk about slide number 9 or 10. The first one is 9. It will talk about strategic implication. Based on these findings, we used lecture 5S data driven decision making framework to drive strategic implication. Our discussion focused on three key areas. Firstly, predictive logistics. By utilizing ONS models, we can forecast demand spikes, aiming to reduce delays by 20% through optimized off-peak during. Secondly, sustainable sourcing. We recommend supply chain using DAFRA GEIC filters with targeting a 125% reduction in emission through the increased adoption of EV fleets. And thirdly, ethical compliance. This involves ensuring anonymized data with using aligning with principle 6 of our ethical guidelines and pushing for water neutrality certification for suppliers. The sequence diagram on the slides illustrates the flow of information for predictive logistics. It shows how honest data provides demand data to demand forecasting. Demand forecasting then predicts demand spikes and communicates this to the logistics system. This continuous loop of data exchange and planning is crucial for delays and improving efficiency, particularly during peak period. And I'm moving to the slide number 10. It is about the table of action partnership. It To the address to the identified limits factors, we propose several key recommendations structured with actionable steps, government partnership, and measurable KPIs. And the table outlines our action plans, the relevant government partnership of collaboration, and the KPI to measure success. For our AI-driven demand routing, we suggest partnering with the Honest Data Science campus, aiming to decrease delays by 20% to improve cold chain efficiency. We recommend cold chain certification in collaboration with the DEFRA farm and with a KPI reducing waste by 30%. Thank you. And I'm moving to my friend. His name is Umar Bhai.
Hi, My name is Mohammad Umar Vaira and my student ID is 23113224. And I am going to elaborate about the slide 11, which is about the conclusion. As we draw our study to a close, our analysis quantified a 30% increase in import costs for perishable goods following Brexit, based on comprehensive HRMC trade data highlighting significant supply chain fragmentation across the sector. So building on this, we developed and validated the first integrated routing model that combines DEFRA's water stress indicators with honest demand spike forecasts, enabling optimized last mile logistics and improved resilience during peak periods. Furthermore, we piloted a senior-centric user interface framework with HUK, achieving a 50% uplift in adoption uh, among older users by simplifying navigation flows and checkout complexity. Looking ahead, we propose extending this integrated government data methodology across other retail verticals such as fashion and home goods to assess its generalizability and support broader supply chain and user experience improvements. The next slide is about the references. Here are the key references that informed our analysis too. The DEFRA's cold chain report provided the sustainability data while the honest retail sales index supplied real-time demand and delivery statistics, that is 23, and the other one remaining as well. Thank you.